Hello, welcome. I shall continue my discussion on static force analysis of 4-bar mechanism. I would like to complete this topic as early as possible, but because I have nothing to teach you, so you need practice. I repeat the same thing I told it in my last lecture also. You need to practice, come up with doubts if at all you have, okay? Otherwise, you understand it, and we shall complete this topic as early as possible. That is why I plan to have a couple of extra classes and complete this, and so that I can go to a topic where I have some role. Okay, so I have another topic, a question which you already have it with you, and this is a question which has appeared in June 2010, and this is for 16 marks. Okay, so it's a 4-bar mechanism as you clearly see it. Of course, this diagram what I have drawn is not really to the scale. Okay, when you draw it, you will come to know the shape of this may slightly change. This may be something like this side also, or this side, depending upon what these dimensions. When you draw it exactly to scale, you will come to know. Okay, so my lecture is only an indicative or the procedure I will be telling how exactly you have to carry on. You really have to carry on and then go ahead. Okay. So now what is this? The question what it says that it is a 4-bar mechanism. AD is framed. The input link number 2, link number 3, link number 4. Please remember all 4 links are binary links. The binary link means a link which is having 2 adjacent links. Okay, so it is not the shape which shall decide whether a link is binary link or not. Please see link number 3, BCE. It is in the shape of a triangle. Don't conclude that it is a ternary link. It is not. It is a binary link. The link 3, which is in the shape of a triangle, and it is having adjacent links as link number 2 and link number 4. The whole thing BCE is a single link. Okay, so now what is the first step? Let us try to solve this. What is the first step? Draw what is called as configuration diagram. Okay, go through the dimensions, all this. The first thing what you need to do, choose what is the scale, probably say 50 mm, 60 mm. Looking at this, I think you can go 1:1, and therefore my scale is 1 centimeter is equal to 10 mm. Okay, so no scale, no reduction, no enlargement also. So I shall start with AD, then first draw what is called as A, and then B, which is equal to 5 centimeters, and then measure 60 degrees, and then draw what is called as AB is 20. Okay, so very small one, say something like this. This is your B. I'm trying to draw as proportionate as possible. Okay, as possible, that's all. This is B. Then BC is 60, almost. So with B as center and 60 mm as radius, we draw an arc. Then with D as center, DC 35 mm, you draw another arc, something like this, join this. Then this is D, this is C, A, B, C, D. Okay. Then you also, the link 3 is not in the form of a bar, it is in the form of a triangle. Therefore, let me complete it. With B as center and BE 45 mm, please draw an arc. With B as center, 45 mm arc, draw it. And with C as center and CE, 20 mm, draw another arc. Okay, this is, so again I repeat, so the shape what I have drawn here is not the clear real indication of the exact diagram. Okay, so now I shall name this as E, and I shall hatch it to indicate that this whole thing is one link. Okay, this is now I shall also mark what is called as point G. For how? By knowing the distance DG equal to 25, so I shall mark G. Okay, so now the diagram is not indicating the mechanism. Let me convert it into mechanism by marking what are called as turning pairs. Okay, where all you have turning pairs, here one, here you have another one, Here you have another one and here you have another one. Please remember, at E you don't have turning pair, don't show. As if B is one link, BC is another link and you have a turning pair. You don't have that. Okay, don't show. Okay, and I know that AD is frame, probably you can fix it. Okay, then this is your link number 1, this is your link number 2, this is your link 3, this is your link 4. Okay, so now indicate the forces. What are the two forces? So they have been called as F3 and F4. F3 and F4. Okay, so F3, the force acting on link number 3. Don't ask me F3 and F4 are given, where are F1 and F2? No. So F3 means the force acting on link 3. F4 means force acting on link number 4. Okay, so what is that F3? F3 is horizontal and acting at point 3. This is what is F3. How much is that? This is given and this is 25 Newton. Similarly, at point G you have a force. How much is that force? 20 Newton. What is that force? F4. Okay, so how is it? It makes the line of action of that force F4 makes an angle of 60 degrees. Okay, so now similarly as in the previous problem, so it is a horizontal line and this is the line of action of F4 which makes 60 degrees. Similarly, I shall draw one more line at G parallel to this horizontal line. Okay, if this is 60 degrees, you know that this also is 60 degrees. The opposite angles. Okay, therefore make use of this. At G, you draw a horizontal line, a light line. Okay, then measure what is called as 60 degrees. 60 degrees. Then you draw a line. So this is the force. Now you put the direction. The direction is like this. And you name it. This is F4. You write down the value. This is 20 Newton. Okay, this completes our what is called as the configuration diagram. The configuration diagram is ready. So what is the next step? Now we shall go for what is called as drawing free body diagrams. Drawing free body diagrams. And before I proceed to free body diagram, what is asked? Okay, F3 is given, F4 is given. What is asked? So we are asked to find out what is the torque that I need to apply on link number 2, which I call as T2. T2 is unknown. I need to find out its magnitude, I need to find out its direction. Okay? So now, okay? So only go through all links. Link 2, link 3, link 4, from where I can start. Link 2, so one torque is there, and one force at A and one force at B. A two force and one torque system. Then coming to link number 3, it is in the shape of a triangle. I have one force at E, that is F3, and one force at B, that is from 2 acting on 3, and there is one more force at C from 4 acting on 3. That means it is a 3-force system. Okay, coming to the free body diagram of link number 4. Link number 4 alone, again I have F4 acting at G and one force at C from 3 acting on 4, and similarly another force at D from 1 acting on 4. Again it is a 3-force system. 3-force system, 3-force system, 2 forces and a torque. So therefore I have a problem of a link which is having only 2-force system. That is what I want. I want to start with a link which is having only 2-force system. That is subjected to only 2 forces. I don't have anything. Therefore, what does it indicate? Indicates that go for superposition. So this is one method, one way what I am demonstrating. Don't think that this is the only way, no. There are other methods which may save little time, but they require a little bit extra interest to learn them, and you can save time. Okay, but the method what I am demonstrating, we shall take little more time, but it will not, you will have very less chance of committing mistake. Go for superposition. What is that? The problem is divided into 2. Okay, what is that? The first part. What is the first part? What is that? assume F3 equal to 0. So assume that you don't have F3 only. Okay, this is first part. And then what is that? The next one. And what is the B part or the second column? Assume F4 equal to 0. When you assume F3 equal to 0, F3 is equal to 0, then link 3 becomes 2-4 system. And if you assume F4 equal to 0, in that case, link number 4 becomes 2-4 member. Okay, so now you have to solve this problem 2 times. Once assuming F3 equal to 0 as if you have only F4. And the second time you have assumed F4 equal to 0 as if you have only F3. Then find out what is T to A. Then I shall call it as T to B. And then add T to A plus T to B to get what is T2. Okay, this is what we have done, and this kind of thing I have demonstrated in slider crank mechanism solution also. So therefore it is not new. Okay, now first let me take this. Okay, so now which is a link having only two forces. So F3 is 0. Since F3 is 0, therefore the link number 3 is having only 2 forces. So draw that free body diagram. The first one, what is that? FDD of link number 3. Please go through this, understand. You have to really work out, then only you will be understanding it. Okay? So when you go through my lecture, you feel that you have understood, but it takes some time. You need practice, then only you will get confidence after solving it. Free body diagram, link number 3. How is link number 3? Link number 3 is the shape of a triangle. Okay, I need to draw that. Okay, so therefore, okay, I didn't tell all this. You note down this angle, etc., to draw this. Okay, I don't take, without taking much time, I shall draw that triangle. Say this is B, say this is C, and say this is E, something like this. Okay, this is E. This is the link what I refer. This is the free body diagram of link number 3. Okay, so now what are the, how many forces are there now? As I have assumed F3 equal to 0, I have one force at B. What is the name of that force? The name of that force is F2, 3. Because this is link number 3. And what is the name of the other force? F4, 3. Okay, so F4, 3 and F2, 3. Where F2, 3 acts? F2, 3 acts at B. Where F4, 3 acts? F4, 3 acts at C. Okay, so now these are the only 2 forces, and these 2 forces must be, what is that? Equal, opposite and collinear. So that means F2, 3 passes through not only B, it also must pass through C. Therefore, the line of action of F2, 3 is along the line BC, the same thing. And the same is true with F4, 3 also. F4, 3 also is like this. I hope it's clear. Okay, so now I have the idea of what is called as the free body line of action of F4, 3 is known. Now I shall go to what is called as the second part, what is called free body diagram of link number 4. This is what I shall go. Okay, this is this. Okay, now I have a link like this. Okay. I'm not explaining how to draw this, etc., etc. I hope you already know it. Okay, this is D, C, the same size, etc. This is D, and here somewhere here I have G. Okay, I have a force what is called as F4, which I know. This is the force which is acting 20 Newton. Okay, so at D I have one force which is that. What is the name of that force? That is F1 force. And at C, I have another force. What is that? What is the name of that force? That is F force from 3 acting on 4. So where this F3, 4 acts? At C. Where this acts? This is at D. Okay. So do you have any idea about F3, 4? Since I have idea about F4, 3, therefore I have idea about F3, 4. F4, 3, F3, 4, they are action and reactions, therefore the magnitude, line of action, they are exactly same, only directions are opposite. Okay, so now I know the line of action of F43, which is along this BC line, and therefore the line of action of F34 is also known. This is the line of action of F34. How did I get this? From this line and this line, they are parallel to each other. Okay, so now there is one more force, this force, this force, this force, three forces. It is a three-force system. So make use of the conditions of equilibrium. The three forces must have a common point. This is part 1. Okay, get the common point of F4 and F34 by drawing this line. So this is the common point of F14 also. So draw from here and draw a line passing through D and something almost like this. This is, please remember, this is line. And what is this? This is your line of action of F14. Now, all the line of actions, two line of actions and one force is completely known. Now go for what is called as force triangle. I want to draw force triangle. Why force triangle? Because it is an equilibrium. The resultant must be 0. If the resultant has to be 0, the polygon will be closed. Okay, in this case it is a triangle. Choose K, say 1 centimeter, K is equal to 5 Newton. So I shall choose a point, this is the point. Okay, the first force I shall draw, F4. This is at 60 degrees to this, 60 degrees horizontal line. Then I draw what as OA. How much? 20 divided by 5, 4 centimeter line, I draw this OA. Then at this point, I shall draw one more force. Anyone, say I shall draw F14, which is almost like this, something like this. So why this side? Yeah, there is no answer. Actually, let me draw it this side also, because I don't know the direction. At the tip of the first force, I need to draw the second force. I know the line of action of the second force, but I don't know the direction. If it is upwards, then I would have, starting from here, I would have drawn this. If I am sure that it is downwards, then starting from here, I would have drawn it downwards. I don't know at this stage whether it is upwards or downwards. Therefore, I shall draw one line. Okay, now, which is the third force? The third force is F34. Okay, again, at the tip of the second force, I am supposed to draw it. I don't know the tip of the second force, but I have the information where this third force ends. The third force must end at point O. Therefore, at O, draw a line parallel to this. Okay, so probably if you had measured angle etc. here, then it would have helped you, and I hope you know that, and draw this line. Now come back and close the triangle. Okay, this is your first force, that is F4, then downwards. What is this? This is your F14. Then you can call this as B. Then next force, this is BO. Okay, this is what is called as F34. Okay, measure BO, so many centimeters, multiplied by the scale of the diagram, that is 5 Newton. That is equal to F34. Go to the diagram here. F34 is no more unknown. I have completely known it. Know it. F34, F14 is downwards. If you want F14, then measure this. AB multiplied by scale is equal to F14. Okay, now you know F34. Please remember, not only line of action, its direction, its magnitude from here. Okay, you know F34. If F34 is known, F43 is known, they are exactly equal and opposite. F34 is towards right, F43 must be like this. Now these are the only two forces. They have to be equal, opposite and collinear. Already collinear, and they have to be equal, okay, and opposite. If 4-3 is like this, then F4-3 is like this. What is the magnitude of F3? It is no more unknown. It is same as this. It is same as this. It is same as this. That means I know F23. I know F23. Therefore, now what is the remaining? The last one, what is called? What is that? Free body diagram of link number 2. Okay, how does it look? It looks like this. And this is what do I am finding? It is not complete T2, and I am finding out T2A. T2 because of the first case, what I call it as A case. T2A. T2A. This is what I am finding out. And at this point, what is this name? This is B, this is A. At B, you have a force. What is that force? The force from 3 acting on 2. What is the name of that force? F32. And at A, what do you have? You have a force, what do you call? F12. So, I have two forces and a torque. The two forces must be equal, opposite and parallel. Okay, so now F32. Do I know F32? F32. If I know or not, check. Do I know F23? Yes, I know F23. F23 is known, then F32 is known. Okay, F32 is exactly parallel to that, and F23 is towards right, and therefore F32 is like this. And you can extend it. And how is F12? It must be parallel to this. Therefore, draw, passing to at point A, draw a line parallel to this. And what is this? F1. What is the direction? Opposite to this. If it is like this, then F1 is like this. And what is this? Perpendicular distance. Let me call it as XA. Okay. Then what is the magnitude of T2A? That is nothing but F32, which you already know, multiplied by XA. This is equal to so many Newton millimeter. Okay, this is what you know. And what is the direction of this? This F32 and F12, they form a couple which is anti-clockwise. And therefore the torque, what I have to apply, T2A, must be in the clockwise direction. Then only it will remain in the equilibrium. If I also apply in the same direction, the whole thing will start rotating. It will not remain in the equilibrium state. And therefore, let me write down what is the direction of this T2A. T2A is clockwise. Please remember, what I have done is only half of the problem now. Now what you have to do? Assume F4 equal to 0. What is the meaning of that? This force is not there. Then link number. What is your starting point? What is your starting point? Draw FBD. FBD of what? Of link number 4. So F4 is not there. You will have one force at D and one force at C. Draw that. Only two forces, F14 and F34. I shall just indicate. Quickly I shall do it. This is link number 4. And I have one force here, which is at F14. Why did I draw it? How did I draw it? Because the two forces are equal, opposite and collinear. So I know F34. If I know F34, the line of action of F43 will be known. I don't know more than that. I don't know its magnitude, I don't know its direction, I know the line of action of F43 also. If you draw the free body diagram of this, you know on this, and you know the force at C, it is same along this. And then get the line of action of the common point of this force and this force. Join that force to this to get the line of action of F23. Then draw force triangle. Then find out the magnitude and direction of F23 and F43. And once you know F23, then draw the free body diagram of link number 2. Then you know F32, both magnitude and direction. And draw the free body diagram of link number 2. Then you know F32. Then you draw F12, get its direction, magnitude. Then find out the perpendicular distance between the two. And then get what is called as T2B. Okay? T2B is equal to F32 multiplied by XB. XB is the perpendicular distance between the two forces. Then find out what is the direction of T2B. Okay, T2 is equal to T2A plus T2B. If their directions, both of them are same, then you can actually add and put the same direction. If they are different directions, then choose which is higher one. Choose which is higher one and subtract the two, and the direction will be the same as that of the higher one. That is your T2. Okay, so telling is very simple, and I can complete telling the method, the whole thing in 5 minutes. I can complete the whole procedure, but it will take quite some time to solve it really when you start doing it. But unless you really do it, you will not be able to understand. This is a highly reliable question from the examination point of view. Please do not take it light, solve it, practice it, and if you have any difficulty, I am there. I shall help you. Okay, all the best.